Hey there, this is 1.1 and 1.2 for Honors Algebra 2, solving linear equations and inequalities. The objectives here, we've got three. Students will be able to translate verbal expressions into algebraic expressions and equations, and vice versa. Solve equations using the property of equality, and solve one and multi-step inequalities. As you can see, the standard is 1.2. ACE.1, creating and solving equations and inequalities in one variable, modeling real-world problems involving linear, quadratic, and simple rational and exponential relationships. We're not focusing on any of that today. So all of that we're not working on, just on linears. Interpret the solutions and determine whether they are reasonable. So let's look at example one. Example one says, we're going to translate verbal expressions to algebraic. Write an algebraic expression to represent the verbal expression 9 less than a number. One key thing when we talk about the words less than. The less than flips the order in which we think about the subtraction. So it's not going to be 9 minus x, it's actually x minus 9. Remember, anytime we hear the words a number, that's just in place of a variable that we don't know. And we can use x, we can use y, we can use whatever variable we want. Example B here, a little bit more complicated, but we've got the cube of a number increased by the product of 8 in a number. So we've got a couple things going on. So cube of a number, so we're talking about a power there, so x cubed. Increase, that's going to be plus, by the product of, so that means the next two things are going to be multiplied together. Well, it says 8 in a number, well, one thing to pay attention to, a number here and the number here have to be the same variable. And so we're going to have 8x. So x cubed plus 8x is translating that one to algebraic. All right. Example 2, going the opposite direction. We want to be able to translate this from an algebraic equation, in this case, to a verbal sentence. And so as we go from left to right, that's the best way to read this. So we have 7 is equal to negative 2 plus x, or we could say the sum of negative 2 and a number. Now, when we translate from algebraic to verbal, you will see some differences in what other students write. So again, some people might say the sum of negative 2 and a number. Others might say negative 2 plus a number. But again, order matters, operations matter, but we do have some play in what terms that we use to get there. Look at the second problem here. We do have a little bit more complicated situation here. We've got a 10x minus 4. So to combine these two, we've got to do a little bit of verbal jujitsu. And so we've got the difference is one route to go. The difference of the product of 10 and a number and 4 is equal to 36. That's one method that we could use there. Another way that we could word this, and I'm running out of space to write it, but we could say 4 less than the product of 10 and a number, like we had back up in example 1a. So again, just some different wordings there that you could see in those examples. All right, as we move along, we're going to talk about some properties of equality. These you should know from before, but as we go, just reflect on them. Well, first one is the reflexive property. And basically, the reflexive property says that a number is going to be equal to itself. So 1's equal to 1, 5's equal to 5, x is equal to x. Or as we see in the example, x plus 5 is equal to x plus 5. We could be a statement more than just a number. The second property is symmetric. And the thing to think about symmetric is to think about a mirror. When you look in a mirror, everything that's on the left ends up on the right. Like think about your webcams when you're taking your selfies, everything ends up on the opposite side. So if A is equal to B, then B is equal to A. And we see here with the examples. You see the 14 is on the left-hand side of the equal sign here, but when we use the symmetric property, it ends up on the right. The statement 2x plus 5 was on the right, it ends up on the left. One common mistake here is that students want to flip the individual sides. So instead of writing 2x plus 5, they'll write 5 plus 2x. With addition, that's not an issue because of the commutative property, but with more complicated statements and statements that don't have the commutative property, it is a thing to watch for. Now, as I mentioned in class the other day, my favorite property, the transitive property, if A is equal to B and B is equal to C, then A is equal to C. So we have some statements here that we connect. So the 2 minus 7, and there is a typo there, I caught it, you don't get house points. And 2x minus 7 is equal to 4. And 4, so we got our 4 here. 4 is equal to 5x plus 9. Then we can take those 4's out of the middle, and we get that the 2x minus 7 is equal to 5x plus 9. Last property that you pay attention to is the substitution property. And if I was doing this in class with you, I would pull out $1.04 and ask you, which one would you rather spend? Well, a lot of you would probably say the dollar bill because it's easier to carry and take to a grocery store. But if you were headed to the vending machines, you probably want the 4 quarters. But the point is that they spend the same. $1 is the same amount as 4 quarters. And so when we think about this with equations, if I've got 2 separate statements that are equivalent, we can replace one with the other. And so A is equal to B, then I can replace it anywhere in the statement. In a simple example here, if I've got 5 plus 3, well, we know that 5 plus 3 is equal to 8, so we replace it with the 8 there. So those are the 4 properties we're going to look at in the next examples. Identifying the properties. In this first property, we've got x plus 7.5 and x plus 7.5. So of our 4 properties, which one's it going to be? Is it reflexive, symmetric, transitive, or substitution? All right, now that you've thought about it, if you said reflexive, you've got it right, because the left side is exactly the same as the right. Remember, reflexive says that a number is equal to itself. Look at example B. If you said symmetric to A, remember the confusion is that symmetric is like a mirror. Everything's going to flip. And so in B, we see 18 is equal to x, and x is equal to 18. They flipped, so that is symmetric. In C, what property is illustrated here? We've got if x plus 5 is equal to 1, then 1 is equal to x plus 5. What happened? This is also symmetric. I tried to trick you a little bit there, but it's the same one, symmetric. Last one here, example D. What property is illustrated by the statement, if 3 is equal to x and x is equal to y, then 3 is equal to y? If we cut out the middleman, all of this going away, 3 is equal to y, so this is the transitive property. Transitive. All right, and by the way, the word of the day is weekend. Again, the word of the day is weekend. All right, addition and subtraction properties of equality. So basically, again, things that you've learned in middle school and Algebra 1, but saying if I need to add something to both sides of an equation, I can, or if I need to subtract something from both sides of an equation, I can, or multiplication or division. Remember, the only restriction on multiplication division is what I divide by or multiply by cannot be 0. And there's another little error that we're going to fix. Equality. Now, so when we look at one-step equations, again, I know this is Honors Algebra 2. I know you know how to do this. We're going to talk about it anyways, just to get through it. So 18 is equal to 1/2 t. What are we going to do to both sides to solve for t? Well, if we're multiplying by 1/2, that would be undoing it would be dividing by 1/2. But dividing by 1/2 is really multiplying by 2. So we're going to multiply both sides by 2. And so the 1/2 and the 2 will cancel. We get t, and we get 36. T is equal to 36. And remember to check your solution. Plug that back in for the t and show that 18 is equal to 18 in this case. So again, the solution is t is equal to 36. Now, if this was on a test or a quiz, would I require you to show the check every time? No. But understand that you should check your work. In B, what's the solution here? X plus 22 is equal to 10. So how do we get the x by itself? Well, we have adding of 22 to that side, so we're going to undo it by subtracting 22. And so x is equal to negative 12. And we check our answer. Negative 12 plus 22 is equal to 10, equal to 10. And so negative 12 plus 22 is 10. 10 does equal 10. So x equals negative 12 is our solution. If you go to multi-step problems, again, all things that you should have done in Algebra 1, just again covering it to cover our basis today. Remember to distribute this one and this one. So we're going to get that 53 is equal to 7y plus 28 minus 6y plus 24. 53 is equal to y plus 28, and 24 would give us 52. And so our next step would be to subtract the 52 from both sides. And we'll get that y is equal to 1. And then again, check that solution, make sure it works. 7, 1 plus 4 minus 3 times 2 times 1 minus 8. And so we get that 53 is equal to 7 times 5 minus 3 times 2 minus 8. And so we're going to get 35 minus 3 and negative 6. That's a negative 8. That'll be a positive 18. And so 53 checks with 53. Okay? So again, going quick here because I know this is a lot of old material. Just we're pushing through to make sure we're starting on the same page today. So, example 5 here, solving for a formula. The formula for surface area of a cone is S is equal to pi r L plus pi r squared, where L is the slant height of the cone. So just to visualize here, we're talking about a three-dimensional cone. And so the slant height would be this length here. Remember, your radius would be the radius at the bottom of the cone. And pi, of course, is pi. And when we're talking surface area, we're talking the outside of the cone and the base. Because this would be the area of the outside part. This is the area of the base. And so we're solving this formula for L. So we've got to get everything else away. And remember that we can treat variables like numbers because they're just numbers that we don't know. And so first thing I'm going to do is I'm going to factor out the pi. I'm going to pull that pi out. R, L, plus R. Actually, we can also factor out an R. So let's do that. So I'm going to delete that R there, and we'll leave an R over there by itself. And so I factored out a pi R. So the R canceled from here, one of them canceled here, both pi's are outside. And now I can divide both sides by that pi R. And so we get S over pi R is equal to L plus R. And to get the L by itself, we're going to subtract the R. And so when we do that, S over pi R minus R is equal to L. Now, you're probably saying, couldn't we have done this another way? Could we have maybe gotten rid of this piece first? Absolutely. That is a second method to get to a similar equivalent solution. And so I could subtract this across first. We get the pi r squared across. So S minus pi r squared is equal to pi r L. And then we divide everything by the pi r. And so right now it doesn't look like these solutions are similar. But remember that we can split this fraction into two pieces, just like if we were doing subtraction of regular numbers. There's our S over pi r that we had over here. And when we look at canceling everything here, the pi's cancel and one of the r's cancel. And so we get S over pi r minus r is equal to the L. So again, a couple different ways to get to the same final answer. Again, it's part of the process. As we look at the next example, gave you a little bit of a freebie here with the 4 options, but when we're solving the perimeter, we're solving for W in this case. Perimeter of just a rectangular prism, or rectangular shape. And so solving for the W, remember we want to get rid of what's not attached to W first, so minus the 2L, minus the 2L. So P minus 2L is equal to 2W. And then we can divide both sides by the 2. That cancels there. So we do get our W by itself. And again, could we reduce this down or leave it as one fraction? It depends on the situation on what you're going to use it next for. I would say let's reduce this down and get it out of one fraction. So P over 2 minus the L, because the 2's over here will cancel. Again, combining 2 steps there into 1. That would be the final there. All right, we are over halfway done. We're almost there. Using property of equalities. So think about those properties of equality. How can we get these to show us a final answer? So we've got an equation here, 5g plus 4 is equal to 4/9. But we don't just want g, we want 5g minus 3. Now one method would be to solve the initial equation all the way down to g, plug it back in, find its value. Or we can solve this equation so it just says 5g minus 3. So how can I get 5g plus 4 to become 5g minus 3? Well, the 5g is going to stay as it is. I don't need to move it. But this 4 needs to become a negative 3. And so what can I do to both sides to get 4 to negative 3? Subtract 7. And so we're going to get 5g minus 3 is equal to 4/9 minus, changing this to 9s will be 63/9. And so 5g minus 3 is equal to negative 59/9. So our answer is that the value would be negative 59/9. Again, you could solve for g, go that route, and then plug it back in and get your final answer that way as well. Either way would work, just whichever your personal preference is. Second one here, so we got 2x plus 6 is equal to negative 5, and we want to know what's the value of 2x minus 4. So again, we got to think about what can I do to this side of the equation to match this. And so that plus 6 needs to go to negative 4. So we're going to subtract 10 from both sides. 2x minus 4 is equal to negative 15. So the value is negative 15. As we look at 1.2, we're almost done here. 2 more examples to go through. Solving inequalities and graphing them on the number line. So remember, solving inequalities, same steps as solving equations. The only difference, remember, if I multiply or divide by a negative, we need to flip that inequality. Again, if we multiply or divide by a negative, we need to flip the inequality. But in this case, we don't have that issue. So we subtracted the 5y and got y. We're now going to add 2 to both sides. And so we get that y is less than 9. Now, some of your teachers might have told you that you need to draw huge, long number lines. I'm not one of those. This is our critical value, the 9 in this case. Put that number smack dab in the middle. Something to the left of 9 is 8. Something to the right of 9 is 10. And when I ask you to graph these, first thing, think about what's happening at 9. Am I going to put a dot or a circle? Again, stuff you should have learned in middle school and Algebra 1. Well, I'm going to put a circle because it's not equal to. And some teachers will tell you, go this way when it points this way. I don't like that method. Use the numbers wisely. Is 8 going to fit into this inequality here? Is 8 less than 9 or is 10 less than 9? Which one's true? 8 is less than 9. This one's not true. And so we're going to shade towards the 8. Okay? Again, you don't need to draw long number lines for me. If it's a compound inequality, which we'll talk about later on, if it's a compound, then you need enough there to know your different critical values. But just for a simple inequality like this, just give me 3 numbers. Give me the critical value, give me 1 to the left, 1 to the right. We're on to example 8 here. Solve an inequality using multiplication or division. And so this is, again, where we're talking about being able to do this, we're dividing by a negative 0.3 in this case because multiplication is canceled by division. We divided by a negative to both sides, so I'm going to flip this inequality. The p will stay on the right. 12 divided by 0.3. 0.3 is 3/10, so I'm really multiplying by 10 over 3. And so I'm going to get negative 120 over 3, which is going to give me negative 40. Again, if you didn't want to go through the decimal, you could use your calculator there, but just doing that on the top of my head. Again, graphing our number line, negative 40 is in the middle, negative 41 to the left, negative 39 to the right. We're going to have a dot at negative 40 because we're equal to in this case. And which number is going to fit? Is negative 40 less than or equal to negative 41? Or is negative 40 less than or equal to negative 39? Negative 40 is less than negative 39. And so our shading will go towards the negative 39. I'm going to skip example B there for sake of time here. And now we go to example 9. Javier has at most $15 to spend today. He buys a bag of pretzels and a bottle of juice for $2.59. If gasoline at the store costs $3.39 per gallon, how many gallons of gas to the nearest tenth of a gallon can Javier buy for his car? And so when we look at this example here, at most, when we think about at most, we're thinking about what type of inequality is going to treat that. And so at most means I can be no more than this 15. So whatever's on the other side has to be smaller than 15. So I'm going to have less than or equal to, because I could be 15. Everything on the left-hand side, he bought a bag of pretzels and a bottle of juice for $2.59. So there's no work to do there. That's just the $2.59 together. If gasoline at the store costs $3.39 a gallon, we can tell this was written a few years ago when gas was a little higher, but we're going to times that by the number of gallons of gas that he needs. We're going to subtract the $2.59. And so subtracting that, we're going to get $12.41. And then we're going to divide that by the $3.39. And we go to our calculator, and 1241 divided by 339 is equal to 3.66. So G is less than or equal to 3.66, but it said rounded to the nearest tenth. So G is less than or equal to 3.6. And so one of my mantras is that word problems require word answers. And so a word answer here would be that Javier can buy at most 3.6 gallons of gas. So again, one of my mantras is that word problems require word answers. And so on quizzes, tests, whatever assessments that we have, be paying attention, word problems, word answers. That is one thing I will look for on those questions as you complete your work. All right. I'm also going to skip this last problem that you see at the bottom for the sake of time, but I hope this has been a good review of solving linear equations and inequalities. Of course, if you have questions, you can stop the video, you can ask, email, anything you need to do. See you in class.